Morning, everybody. We're going to continue our look at functions this morning by going over a topic that we went over in Algebra 2, and that's going to be talking about the domain and range of functions. So, as a reminder to you all, the domain is the set of values that the horizontal axis of a graph can take, and those are usually the x values. And then we have range, which is the set of values the vertical axis of a graph can take. This is usually the y values of it. So we're going to talk about 3 ways that you can describe domain and range of something. So with that, the first thing that you have is a number line. So this number line right here, this is for x values here. This is an open dot. Let me zoom in so you all can see that open dot on 5. And it's a closed dot on 9. So basically what this says is that the value of 5 is not included, the value of 9 is included. So a number line graph is one way to do that. The next way that you can do this is something called set notation. And so with set notation, you use these brackets right here. And the way that this goes is that you say x is a number. This little bar right here means such that. So the way that you read this, x such that, we'd say 5 is less than x, and it's a less than because it's an open dot right there. And then with 9 is a closed dot, it's included. We're going to say, or x could be less than or equal to 9, and that's it. Basically what that says right there is that x is a number such that x is between 5 and 9, where 5 is not included, it doesn't have the equal to under it, or 9 is there. 9 has it because it is included. So the other way to write this right here, this is set notation, this is set builder notation. The other way that we could demonstrate this domain right here is using interval notation. Now, interval notation, the only things we use, we're going to say, okay, well, it goes from 5 to 9, but we need to write the symbol. So you're going to use a bracket if it's included. So if it's a closed dot, if it's equal to, then you're going to get a bracket, and you're going to use a parenthesis if it is not included. That is the accepted math notation that we use here. So we're going to say, okay, well, 5 is not included here. It's going to get a parenthesis. 9 is included here. It's going to get a bracket. So then we're going to look at another example of this. We're going to look at another example. So we've got a number line here, and what this says is that the acceptable numbers for x, according to this number line, 9 is included and to the right, 5 is not included and to the left. So I want you to think to yourself for a second, okay, we've got 2 different portions of this graph. I don't know why this pen doesn't want to work all of a sudden. It'll be all good. So x such that. So the first interval that we've got here says it's from 5 and to the left. So that means that x is going to have to be less than 5. Or, I'm going to switch pens here. This is just not working out well for me. Or, the other thing that could happen is that x right here could be greater than or equal to 9. These are our acceptable values for x. So this is the set notation for it, the SN, if that's what you want to call it. So then the interval notation, because we do need to be able to write both of these, the interval notation here says, okay, if we're going all the way to the left, what number would that represent on a number line? Would you go -5, -6, -7? That would be negative infinity. That gets a parenthesis. You can't include infinity all the way to 5, which is also going to get a parenthesis. Now, in interval notation, the way that you denote or is you use this union symbol. This is negative infinity to 5, or, and then let's go ahead and write this one real quick. So 9 is included, comma, and it goes all the way to the right. We're going to say to infinity. So the first skill that we're going to practice today is going to be talking about domain and talking about the range. So we're going to look at an actual graph now instead of going back and forth from those. So when I ask you to give me the domain and the range of something, you can use any of those forms. Preferably, for my sake, I prefer to grade interval, but if you want to use set notation, that's fine. Number line graphs typically won't be used. Like if you're looking in the answer key in the back of that book, you probably won't see a number line notation because those just take a little bit more room. So we've got this graph right here, and we want to say, okay, what are the domain, what are the possible x values and the range of this function? What are the possible y values? So again, we want to start with the lowest to highest. So when we're doing domain, we want to look how far left does this graph go. So if we're on this graph, we go all the way to left. That arrow right there means we're going to keep going further and further and further left. So if we're writing this in set builder notation, we're going to say x is such that the furthest left that it goes is negative infinity. And we're going to say that x is, so negative infinity is less than x because that's the smallest number we have. And then the graph all the way to the right stops right here at this coordinate, this x value of 8. So we're going to say that that is less than or equal to, x can be all the way less than or equal to 8. And if you wanted to write that, let me close off this room right here, as just an interval, so this is set builder right here, or set notation. The interval would just be negative 8, comma, or negative infinity, excuse me, to 8. So then with the range here, with the y values, again, we always want to start off with the lowest y value first. So the lowest y value on this graph, the lowest this graph can get, if you're looking at this axis, is here at negative 2. So negative 2 is the lowest it gets. That's a solid coordinate right there. So we're going to say less than or equal to y less than or equal to. The highest this thing gets is going to be this arrow going upward. So we're going to say all the way to infinity. And the interval notation for that would be that we'd say the lowest it gets is negative 2 with a bracket. The bracket means equal to as well. And then we're going to go all the way to infinity. I realized I just made a mistake. That should not be right there. Excuse me about that. I apologize. So then on B over here, I want you all to see if you can get this without Mr. Price running through it. I am going to write the answers here, but I want you to pause this real quick and see if you can write these for me. So let's see. The set builder is going to be x such that the furthest left this goes, we have an arrow left, will be negative infinity is less than x is less than infinity. You may see this denoted. If you can go negative infinity to positive infinity, you may see this written in shorter notation here that says x is an element of the real numbers. The way that you read this here is x is an element of the real numbers. So that just that's just a bigger way of saying x can be any number. If it's between negative infinity to positive infinity, it can be any number. And again, the interval notation here would be negative infinity to positive infinity. And we're going to put both of those in parentheses. You cannot include infinity. So then the range here, the lowest that this thing gets, so let's see, is y such that the lowest this graph gets is here at -1. That's the y value. We're going to say is less than or equal to y is less than or equal to the highest that it gets. These arrows go up for forever. And I did it again. I don't know why I put less than or equal to infinity. I don't know. It's late. That's the only thing I can think of. So we're going to say -1 to infinity, or y such that -1 is less than or equal to y is less than infinity. So in a nutshell, so far, all that we've talked about is describing possible x and possible y values of functions using domain and range. There's a couple of different ways to do that. You can pick your favorite one. We can go from there. So then, algebraically here, occasionally we're going to have to think about when we're looking at functions, how is that going to affect the domain and how is that going to affect the range? For example here, if we have a square root of x minus 5, we need to think about, okay, what types of numbers can I not take the square root of? When you're taking a square root, there are specific types of numbers you cannot square root. So there's no negative numbers in square roots. You get imaginary numbers, and we can't graph an imaginary number. At least not in this point of math. There is a point, but we're not there yet, y'all. So what that means is that whatever's underneath here, whatever's underneath this radical, this x minus 5, for it to mathematically mean it cannot be negative, we're going to say it's greater than or equal to 0 because it's underneath that radical. So for the domain here, for the values of x, we're going to say that, okay, to solve for x here, we're going to add 5 over. So x is going to have to be greater than or equal to 5. So when you're thinking about the range here, you can look at a graph of this function. You can start punching in values, but you need to think about what happens if I punch in 5 into the square root of x minus 5. Well, I'll get the square root of 5 minus 5. That will give me a y value of 0. And then you can go from there. What I would recommend doing is if you have something to graph it on, let's see here. Is this going to show my graph all right? I don't know if this is going to turn out right. We're just going to see what it looks like. So x minus 5 here. So here Mr. Price is on the good old Desmos app. I apologize if that's a little bright. Let's see. Can we see? Oh, that is perfect there. So you can kind of see here. It goes through. It crosses at 5 and for the domain. So it goes from 5 all the way to the right. And for the range of this graph, it's going to start at the y value of 0. So this is our domain right here. And then our range is going to go from 0, and it's just going to keep going upward. So for the range, we're going to say that y such that y is greater than or equal to 0. Y such that it is greater than or equal to 0. So then on the next one here, where we're talking about the domain and we're talking about the range here, we need to understand when we have a fraction, with a fraction, you cannot divide by 0. You are not allowed to have 0 in the denominator. You physically break math. Mr. Price would be without a job if you could do that. So what we do for the domain is that we take x minus 5 here, and we say it cannot, will not, shall not be 0. And so what that does is that just tells us that x cannot be equal to 5. So from there, what we have to say is, okay, if I want to list this in set builder, if I want to list this in interval notation, so interval notation, or set builder, excuse me, we're going to say x such that x cannot be 5. The assumption here is that x can be anything else. And if you were going to write that as a interval, we're going to say from negative infinity, so all the smallest number you can think of, all the way up to 5, not included, or 5 not included, all the way to the biggest number you can think of. So we're going to include it here, or we're going to write all the numbers except for 5, and then from 5 to the biggest number we can think of. So that's just a way to exclude 5. So then I'm going to go back and graph 1 over x minus 5 here. So again, if you don't have the Desmos app, I would probably get this or some other kind of graphing calculator app. It is pretty sweet. So if you all look here, when you're looking at the domain and you're looking at the range here, it looks like it's getting real close to 0 here on both ends, but it doesn't cross the axis ever. It just gets very, very close. And we'll talk about more in a second what that is. But with the range here, it gets basically all the way to 0 without getting there. So for the range here, it's going to be all numbers except for 0. So when we write that, we're going to say y such that y cannot be 0. And you all can go ahead and write the interval notation for that as well. Let's see, that would be negative infinity to 0, union 0 to infinity. Because if you think about it, we can't divide 1 by anything to get 0. There doesn't exist a value for that would work. So then the last thing that I want to look at is just looking at straight from a graph. So actually no, we'll be fine. We can look at this without a graph. So again, we're combining both of the things that we looked at in the last problem. We got the square root of x minus 5. So again, we're going to have to say that x minus 5 has to be greater than 0. We cannot have a number in this square root. Now, we can't say it's going to be equal to 0 because if we had it equal to 0, we would get some kind of crazy division there. So we're going to add that over and get that x has to be greater than 5. And for the range now, I do want to look at this graph. If you zoom out on this graph, you see it gets real close to crossing 0, but doesn't. So the range there, I'm just going to shorthand this in interval notation. So this was our domain over here. Domain's always x. So our range is going to go from 0 all the way to infinity. And so that in a nutshell should be a refresher of domain and of range. And so the last things that we're going to look at here are we're going to look at some features of graphs. So as a reminder, some of the features of graphs, we've got intercepts. So we've got x-intercepts, which are like these guys right here. And then we've got the y-intercepts. So I'm going to highlight that in pink and label that. So it's just wherever it crosses the x-axis, it's wherever it crosses the y-axis. Those are your X and Y intercepts. Some sort of new information from Algebra 2, but just to refresh it for you all. So we have things called turning points, which are just, they're kind of labeled aptly. So wherever your graph turns, changes directions, we say that is a turning point. And so we refer to those as, if it's a high turning point, we say it's a maximum. If it's a low turning point, we say that it is a minimum. So this is some other language that we can use to describe graphs. Now, the last thing here that we can use to describe a graph is using asymptotes. So asymptotes are lines a graph gets closer and closer to, but it will never ever reach that point. It's almost like an electric fence. You can get really close to it, but cannot cross it for some mathematical reason. And depending on whether it's a vertical or horizontal, that reason will vary. So vertical asymptotes occur when x is in the denominator. When there's a value that x cannot be, basically whatever x value will make that denominator 0 is where you'll see a vertical asymptote. And then for horizontal, you'll see these in rational functions. So functions that are ratios or fractions, or you'll also see them in exponential functions. So when I'm asking you to talk about these features of graphs, you are not expected to graph these by hand. So we do need to make sure that we have some sort of graphing technology that we can use, whether that's a TI-84, whether that's a graphing app on your phone. We do need some way to look at these functions. I'm going to be using the Desmos graphing calculator app. I think it's great. So I'm going to graph this real quick. So let's see here. You all get to watch Mr. Price struggle to graph this. So 2 to the, already struggling to hit the 1. 2 to the x, let's go to the right. What is it? Divided by x to the right. And then we're going to go minus 2. And this right here is that graph. And so what we want to do first off is say, okay, what are our intercepts? So it looks like to me that we're not crossing the y-axis at all. There's a vertical asymptote there at 0. And we'll get to that in a second. But the intercepts here, if you zoom in, it kind of looks like that they're crossing. So the cool thing about Desmos is that if you think something's there and you click on it, it'll typically tell you there. So like right there, if we think that's an x-intercept, we'll say, okay, well there's 2, 0. That's one of our intercepts. For the x, oh, what's that there? That does not have a y-coordinate of 0. That is not a y-intercept. What about that one? That is 1, 0. So the y-intercepts here for this graph are actually that there are none. So then the next thing that we want to say is, are there any turning points of this function right here? So is there anywhere on this graph that it changes directions? Because this one's kind of decreasing the entire time. It's just going down slow and then fast. Now this piece of the graph is going down and then it changes here. So again, typically if there's something intuitive like that and you click on the graph, it'll point it out for you. So this graph has a turning point. It's a minimum turning point. So min TP at 1.443, negative 0.116. I guess I can put a 0 on the other side there. So then the last couple things that we're going to do are find any asymptotes of this function here. So let's see, the asymptotes here. We have to ask ourselves, so if we're looking at the original function here, 2 to the x divided by x, the vertical asymptotes occur wherever like they're vertically getting close to. So if you look at this, is there a vertical spot on this graph where they're getting closer and closer to, and where it doesn't look like it's going to cross. And to me, it looks like it's that x equals 0 right there. Let's see if we can graph that too. X equals 0. There we go. There's that asymptote right there. So then we'll say that x equals 0, that's our vertical one. And then to me it looks like there's a horizontal one as well, because where this is leveling off here, we need to figure out what y value that is. So I'm going to zoom in on that. So that looks like to me that that's occurring around -2. So our horizontal one, our horizontal asymptote here is going to be y equals 2. So these are the two values that aren't going to occur for your domain and for your range. Everything else is going to be fair game. So when we write those, we're going to say, okay, I'm only going to use set builder here, because this is going to be a lot easier for me to write. So x such that, so x can't cross 0. X cannot be 0 here. It doesn't cross 0 here. And for y, we're going to say y such that y cannot be 0. So we're going to cut it there for today, because for right now, I don't know of a great way for us to sketch all of this. I guess we could sketch the graph for it, but I don't know. I'm going to think of a better way to do that. So if you all have any questions, please join on Zoom, shoot me an email, do something to let me know, and we can get going from there. But thanks, guys.